For LAB5 part A, we're going to construct the FET transfer curve. So first we construct a circuit that consists of two voltage supply, VDD and VGS, a resistor, a field effect transistor with N channel, a ground. So we vary the value of VGS from 0 to -4. After that we run the simulation using the multi-sim live simulation. Then we observe the drain current ID. So we can see the drain current will decrease to approximately 0 when the VGS become more negative. So after obtaining the result, we can construct the curve, the transfer curve, that is ID versus VGS. From the curve, we can see that the relationship between the ID and VGS, it shows that when ID increasing exponentially, the magnitude of the VGS is decreasing. So we go into part B. We want to construct the FET characteristic curve. So we will use the same circuit as in part A, but this time we will vary the value of VDS, that is from 0 increase to 12 volt. So when VGS equals to 0, the drain current ID will increase as the VDS increase. But when VGS becomes more negative, the rate of increasing of the drain current will become lower. So we know that as VGS becomes more negative, the field effect transistor will pinch off at a lower voltage. That means the ID will decrease when VDS is increased. So this is our simulation result. For -1 VGS, -2, -3, -4. So we can now we can construct the characteristic curve of VGS. So this curve is ID versus VDS. So from this curve, we can actually obtain the saturated drain to source current. So we can obtain from the VGS equals to 0, the highest point that's here. Actually, this is the saturated drain to source current. So in this case, we know that the saturated drain to source current actually is 8.2192 milliampere. So that's all from my group. Thank you.